In this video, we'll solve the equation that has the square root of the expression negative 3x plus 10 equal to x minus 2. At the end, we'll formally check each of the solutions we find. The first thing that we need to do is recognize that this is a radical equation. And since it has a radical, there are specific steps that we will take to solve it. So I'm going to identify that it's a radical equation. And what I'll need to do then is isolate that radical. And then because the radical is a square root, I will square each side. And squaring each side will give me access to the variable that's currently inside the square root. So once I've done that, I will finish solving. Generally what results is a linear or a quadratic equation. So let's get started. We have the square root of the expression negative 3x plus 10, and that negative 3x plus 10 is all inside that square root, and is equal to x minus 2. So we've recognized that that is a radical equation. The first thing we want to do is square each side. And we have to make sure that we do this to both sides of the equation to keep things consistent. Now that we've squared each side, we have the square root of the expression negative 3x plus 10. That quantity is squared. So on the left side, we're just going to have negative 3x plus 10 now. On the right side, we have the expression x minus 2 quantity squared. So to simplify that, we'll remember that it's x minus 2 times x minus 2, and we can go about foiling that or using shorter methods for expanding it. So I'm going to take x minus 2 times x minus 2, and when I expand that, I'll get x squared minus 4x plus 4. At this point, I want to think about what type of equation I have. I have negative 3x plus 10 equal to x squared minus 4x plus 4. That equation is quadratic. So in order to solve it, I'll want to set it equal to 0 and then use methods for solving a quadratic equation. So setting it equal to 0, I've got x squared minus 4x plus 4 on the right, negative 3x plus 10 on the left. So I'm going to add 3x to each side, and I'm going to subtract 10 from each side. So on the left, I'll have negative 3x plus 10 minus 3x, plus 3x, and then minus 10. That will be equal to x squared minus 4x plus 4, and I will add 3x to this side as well to keep it balanced and subtract 10. Now I'll be left with 0 on the left-hand side, and when I simplify that right side, I'll have x squared minus x minus 6. To solve this, I'm going to use the quadratic formula. So I have x squared minus x minus 6. Using the quadratic formula, I can make that so that x is now equal to, and it will be the opposite of b. b is my coefficient on x, so the opposite of negative 1, and then plus or minus the square root, and inside here I want b squared minus 4ac. So again, b was negative 1, I'll square that, minus 4 times a is 1, times c is negative 6. So I have in the numerator the opposite of negative 1 plus or minus the square root, and then inside there I have quantity negative 1 squared minus 4 times 1 times negative 6. That's all over 2a, so that's all over 2 times 1. Simplifying this, in the numerator, I'll have 1 plus or minus, and then I'm going to simplify what's inside that square root. I have negative 1 quantity squared, which is 1, and then minus 4 times 1 times negative 6, so plus 24. So I'll have 1 plus 24 inside that square root. That's all over 2. And now I can break this into, that'll be the square root of 25. So I'm going to simplify that. I've got x equal to 1 plus or minus that square root of 25, which I know is 5. So I've got 1 plus or minus 5 all over 2. Now I want to break this down. I know that this will be some type of rational number, so I'll have x equal to 1 minus 5 over 2, or x equal to 1 plus 5 over 2. That first one, 1 minus 5, that quantity over 2 will become negative 4 over 2, which is just negative 2. For the second one, I have 1 plus 5 over 2. That'll be 6 over 2, which is 3. So at this point I have two proposed solutions, and the two proposed solutions are -2 and 3. It's important when we're solving radical equations that we always formally check our solutions. And when we're checking, we're not actually checking to see that we made an error per se, although we'd find it if we did. We're checking to see if any of these are false solutions, or solutions that were presented by the methods we used but don't actually check back into that original equation. So I'll go through and do the checks here. First, I will check that first proposed solution. So for x equals -2, I'm going to put that into the original equation. So I will take the square root of -3 times -2, and then I'm adding 10, and that's all inside a radical, and I'm going to check if that is equal to -2 minus 2. So I had x minus 2 on the right, I replace x with 2. When I simplify this, on the left I'm going to get the square root of 6 plus 10, and then I'm checking if that's equal on the right to -4. Now at this point I should be a little suspicious. The principal square root or the positive square root will never be negative, so I'm going to continue simplifying and I'll see what happens. The square root of 6 plus 10 is the square root of 16, so I'm checking is that equal to -4, and the square root of 16 is +4, so that is not equal to -4. What that tells me then is that -2 is not a solution. It's what's called a false solution or an extraneous solution. Continuing on, I'll check the second proposed solution, which was 3. So I'm going to check that proposed solution of 3. I'll go to that original equation, and I'll take -3 times +3 plus 10. And I'm checking if that equals 3 when I replace that with x minus 2. So on this left side, I'm going to have the square root of -9 plus 10. I'm checking, does that equal 1? And the square root of 1 is what that left side simplifies to, and that does indeed equal 1. So the only solution is 3. And that means that the solution set is the set just containing the number 3.